In this video, we're going to talk about implicit differentiation. The big difference between regular differentiation and implicit differentiation is the way y is defined with the function. Explicit, which is the way we were doing it before, is when y is defined plainly just by a function of x. Implicit is what we're going to be looking at for this video. It's when y is not straight out defined. So we have, for explicit, we have y equals some function. For implicit, y is intermixed within the function itself. So we have y squared and negative 7y and whatnot. So basically y is not by itself. And the way to find the derivative of these implicit functions, we're going to find the derivative of each term with respect to x, and then eventually we're going to be able to solve for dy dx, which is the derivative of the function. Alright, so I know that last slide might have been a little confusing, so I'm hoping to clear some stuff up with this slide. So we were given a function and we were trying to find y prime, and basically y prime is the same thing as saying dy dx, the change in y over change of x. Alright, so we're just going to take the derivative with respect to x of both sides of the equation. So let me start by rewriting the equation. Alright, so we're given that equation and we want to find the derivative with respect to x. So I'm going to take the derivative with respect to x of both sides of the equation. Okay, and remember we're looking for dy dx. So let's just evaluate the derivative so far. We have the derivative with respect to x of 2x cubed. That's something that we've been seeing a lot. We know how to do that very easily. It's the power rule. So we're just going to do 3 times 2, which is 6. And next to the squared. Okay. Now we have 2y squared d over dx plus 5d dx. Alright, now we know that the derivative of any constant is 0. So this is going to go to 0. But the tricky thing is we got this 2y squared d dx. We're trying to take the derivative of 2y squared with respect to x. Well, there's no x there, so how do we take the derivative? What we could do is do a little bit of arithmetic. But before I do that, I need you to acknowledge that this arithmetic statement is true. We have d over dy, so the derivative of a term including y, times dy dx is the same thing as d over dx. Just by canceling these two out, we get this statement. So what I'm going to do is I'm going to plug all this stuff in for d over dx. So we have 2y squared d over dy times dy over dx. And we got 6x squared. Remember, we didn't change the function or anything. We just rewrote it differently. Now we can take the derivative of this fairly easy, since we know what 2y squared d over dy is. So now we have 6x squared. We're going to use the power rule. So the derivative of 2y squared with respect to y is just 4y. And we're left with dy dx. Okay, this is what we're solving for. We're trying to get dy dx, and we have dy dx. So now we just divide both sides by 4y. Now we can simplify. So 6 divided by 4 is 3 halves. We have y on the bottom, and we have x squared on the top. Okay, we just found dy dx. We just found the y prime of that implicitly defined function. Now some highlights. We started by taking the derivative with respect to x to both sides of the equation. We found the derivative of 2x cubed and 5 pretty simply. We ran into a speed bump when we had 2y squared trying to take the derivative with respect to x. So we just rewrote it differently. and use substitution, took the derivative of this guy with respect to y using the power rule, found dy dx, which is what we were looking for, and that was it. We'll do one more example and then I'll have some examples for you. Okay, here's another problem, same idea. It's just going to be a little more complicated because we have x times the y here, so we're going to use the product rule. So, we want to find y prime, which is the same thing as dy dx, remember. Okay, so we're looking for dy dx. So we're going to take the derivative with respect to x to both sides. On the left, it's pretty fairly simple. That's just using the power rule. So that's going to be 15x squared equals -3. We run into a little speed bump with this -3xy dx, but the derivative of any constant is just going to be 0. So now we're going to use the product rule. So we have two functions. We have -3x and we have y. So we have -3x and y. So I'm going to take the derivative of the second one with respect to x. So we got y times -3x plus the derivative of -3x with respect to x. So that's just going to be -3 times y. Now remember, okay, so we got to take the derivative of y with respect to x. Remember that little trick we used last time? So we got y dy. The derivative of y with respect to y is just 1. So we have 1 times dy dx, so it's dy dx times -3x minus 3y. And this all equals 15x squared. Now we just got to solve for dy dx. So I'm going to add that 3y to both sides. We have 15x squared. And then last but not least, divide both sides by 3x. Oops. Dy dx is all by itself. We found y prime. Alright, after seeing this video, you should be able to at least try these. Number 1 is a little more straightforward. Number 2, you're going to use the product rule over here. So just giving them a try, and we'll answer all questions and we'll practice more in class.